Alright, so working on the warm-up. Alright, so I want you to list the 6 basic trig functions. So this should be fairly simple. What are the 6 basic trig functions?
Sine, cosine, tangent, secant, cosecant, something, cotangent.
No, Jasmine, keep bringing it down.
Cosecant, secant,
And cotangent.
and cotangent. Okay, so you've listed the 6 basic trig functions. Now, I want you to take each one and write it in terms of its reciprocal. Do you need an example?
Like
Yes.
minus 1
Yes.
over opposite.
That's the definition. Like, that's how we find it.
So it'd be 1 over.
But we're talking about, like, the reciprocal. So what are you saying, Kara?
Negative 1 over sine.
Negative 1 over sine. What's negative 1 over sine?
Cosine? No.
Example over 1 or 1 over sine.
Okay. So what's the reciprocal of sine?
Wait, it just has to be 1 over sine, not.
Huh?
It just has to be 1 over sine, right? Not negative. That's not reciprocal. Continue.
So, okay. So what's the reciprocal of sine? Is what? 1 over sine, or what do we call it?
Half.
I don't know why I said half. I'm sorry.
Sine inverse.
Like inverse.
Inverse sine.
Okay.
I know.
So, oh, wait, okay. So you said that the reciprocal of sine is 1 over sine.
Yeah.
Okay. So if we have 1 over sine, do we know this by another name?
Sine and 1. Like
Inverse
inverse
sine.
sine.
Reciprocal
No, like
of
it's
sine.
cosecant.
I don't.
You feel like it's what, Brett?
Cosecant?
You feel like it's cosecant?
Thing.
So do I. I feel like it's cosecant too.
There's a point where you just have to stop trying to.
So remember, when we're talking about cosecant, how do we define cosecant? What is this?
1 over sine.
It's 1 over sine. So I want you to do that for all 6. All 6. And then we're going to explain why this works, why we can write them that way. We're going to kind of look at it.
I'm sorry, does it say proofs at the top?
It does.
In geometry. That's the worst. That's a typo, right?
It is not. You
Chelsea
guys
and I
will
are
be
having
fine.
flashbacks to geometry.
Geometry proofs.
Yeah.
Geometry proofs are
Alright.
the reason I failed.
So don't worry about the proofs just yet. Work on the warm-up.
So I pushed that back so far I can't
Kara's
remember.
fainting again.
You guys at least noticed the proofs. The second hour didn't even notice it.
Lucky that.
Okay, so.
It's too late to drop.
So, okay, the next one is what?
Oh, you want to go over them already?
I mean,
Or are you ready, Shemaya?
Shemaya's got it.
I just,
Got this, Chad.
this has
Make
been a
it way
long
more.
week.
Hey, I know.
This is literally the longest week of school I've ever had in my life.
Alright.
It's only for
Okay.
an hour of the first day back.
Alright, so let's look at these then.
Alright.
Alright, so we said that cosecant was 1 over sine.
Yeah.
So what other ones can we do?
Secant is 1 over cosine.
So what?
Secant is 1 over cosine.
So secant is 1 over cosine.
I've had enough.
Nick, what's cotangent?
It's 1 over tangent.
Is 1 over tangent.
Like I wasn't paying attention.
Alright, so these 3 should be fairly easy because we know that that's how we define cosecant, secant, and cotangent, right? So the ones that you might be having an issue with are the sine, the cosine, and the tangent. We want to write them in terms of their reciprocal.
Would it be 1 over cosine?
So would it be what?
1 over cosecant?
So it would be 1 over cosecant. Now how did you figure that out, Shemaya?
Cause, that, since,
No, come on.
okay, since, the cosecant is 1 over sine,
Uh-huh.
and that's how you define that, so wouldn't it be like?
So
opposite
then,
of that?
so you're just solving for sine, right?
Yeah, you're
From
just-
over here?
Minimum.
Okay,
Pretty
so
much,
that,
yeah,
that's a legitimate argument.
it is.
Can you
That's
prove
what I
that?
smell.
Alright, so what about cosine?
Because I.
It's 1 over secant.
It's 1 over secant,
And tangent is 1 over cotangent.
and tangent is 1 over cotangent. Alright, so now we want to actually look at each one of these in terms of how we define them. So going into what you said, Nick, that we use the opposite, the hypotenuse, the adjacent, all of that stuff. So now we want to actually go into that. That's going to help us explain why this works.
So now instead of so, it's show.
So,
You got
okay.
H over O.
So for sine equals 1 over cosecant, how can we explain that?
1 over 2?
If we go, so we want to get this to equal sine again. What did sine equal when we defined it?
1 over 2? Or, I mean, the opposite over hypotenuse?
So it's opposite over hypotenuse, and that's when we're talking about like our triangle and
So
our,
now it's a hoe.
hey,
H0. Not 0. The letter O.
Okay,
Leave me alone.
Ho ho ho!
You know what I meant. Like.
okay. So we want to get this back, we want to get this to equal this.
He's
Okay, yeah.
Santa.
Right? Because that's what we're doing. When you're proving identities, you want to prove that one thing equals another thing.
Okay, then that's 1 over,
I need focus.
1 over hypotenuse.
So, okay. So what are you saying, Shemaya?
It's 1 over H over O.
Complex
So we have
fraction.
hypotenuse over opposite, right?
Yeah.
Okay, so then how do we solve that?
You multiply the 1 over H by O.
You do what?
I don't know. Or you multiply the sine by
What is this? This is a complex fraction, right?
Yeah. So you got
So how do we solve a complex
Flip it.
fraction?
Yeah.
Multiply by.
You have to flip and multiply.
Yeah.
flip and multiply regime.
So you have the top is 1. If we flip and multiply the bottom, so doesn't that give us back our sign?
Yes, it does.
That does.
So that explains why we can do this in terms of the reciprocal.
Alright, that's fair.
Alright? So, Kara, tell me how to do the cosine one.
Adjacent over hypotenuse,
Okay?
and then 1 over hypotenuse over adjacent.
Done.
Now what?
Flip and multiply.
It's just fun to say. Where's Laura? God, someone get her in here.
She's gone.
We're back.
Alright, Regine, do tangent for me.
Okay. Opposite over adjacent.
Is that mandatory? Do you have to write that part, or is it just a
This is just so that you recognize why they work.
Okay.
Why we can write them the way that we can.
Okay.
Alright, so what else we got, Regine?
1 over opposite over adjacent.
It's 1 over what?
Sorry, adjacent over opposite. Opposite, yeah.
Okay.
You multiply, you flip and multiply that stuff. And yes.
I didn't flip it.
You didn't flip it?
I didn't.
Ayo.
Oh,
I didn't flip it.
look, honey, it's been a long day. I'm used to it.
Jesus, honey, it's late.
Look, honey. Like, I have a
Alright.
squished in my backpack.
Okay, so that's the first 3.
Yeah.
Can you guys explain the last 3?
Okay, so now you're gonna take the inverse that you just did, so it's gonna be like, so you're gonna have the H over O.
I don't want to.
You don't want to?
Cosecant.
So what do we have? 1 over.
Over H times 1 equals 1 times H over O.
Gives you the H over O.
And then the same thing for those 2.
Yeah.
So
All
all
right.
you're doing is the complex fraction that you get is 1 over the opposites function. So, there it is.
So these are actually 6 basic trig identities. We're going to use these when we're proving
Basic.
other identities. And these are ones that you should already know. These go back to chapter 6, before that. So these are ones that you're already familiar with. So now we're going to actually look at new ones. And those are the 3 Pythagorean identities that are on your notes.
Me too.
So I'm going to write all 3 over here. And then we're going to look at each one individually.
Shemaya, we're learning a month
Cotangent to the second.
Oh, thank you.
Yeah.
I forgot which side it started with.
Less than a month away. Actually, just try.
I graduate in 32 days, you guys.
Okay, so these are our 3 Pythagorean identities.
That's what we.
So now we want to actually find where they come from. Because I just gave them to you, so there they are. But we want to actually look at where they come from, how we find these. So if we're looking at the first one, we have that cosine squared x plus sine squared x equals 1. And if you look on your paper, you have a unit circle. My unit circle isn't going to look nearly as nice because I can't draw a circle. But, you know.
Pretty good.
That's okay.
It's pretty good? Alright. It's better than it was second hour.
You should like a square.
Okay. So, if we're thinking Pythagorean identities, what do you think
Right
the Pythagorean
triangle.
identities are going to deal with?
Right triangle.
Right triangle. So, I want to draw a right triangle in my unit circle.
Don't we all?
You should. It's fun. So we have some random point x, y, right?
Yeah.
And that's how we draw in our triangle and our unit circle. How can I label my sides on my triangle?
Opposites.
So yeah, we have a hypotenuse, an adjacent, and an opposite side.
Yeah.
But what can we call those if we're given this, that we have this random point x, y?
A, B, C.
Yeah, 0. Just one.
So, okay.
Y.
So what?
X and Y.
Where?
X is the bottom one.
X is here,
And Y is the one going.
and y is our side. Because remember, if we're looking at some point x, y, we've gone over x units, so that's how far we've gone over, and we've gone up however many y units we've gone up. So then what's our third side, if this is the unit circle?
Z.
Z.
Word.
What did we call this in a circle?
Radius.
Okay, so what did we call that in?
R.
So we called it R.
Pirates.
I have a bunch of pirates. Alright. So now, if we're thinking Pythagorean identities, what do you think we're going to have to do with this triangle?
Find them.
What?
Find them.
Find what?
The X, Y, R dots.
So so Shemaya, what'd you say?
I said maybe we're doing the Pythagorean theorem.
We might be doing the Pythagorean theorem if we're dealing with a Pythagorean identity.
Oh yeah. Oh yeah.
So,
Get out, Richie. Leave.
so if we're doing the Pythagorean theorem,
Love me.
what does that tell us about how do we write the Pythagorean theorem for this triangle?
You know,
X squared.
X squared plus Y squared equals R squared.
Okay, so we have x squared plus y squared equals r squared. You guys have done the Pythagorean theorem a million times.
Have I?
I think a million.
Well,
a
alright,
little
probably exaggerating. But.
Never believe you.
Roughly
Okay.
500 maybe.
So what we ultimately want to do is transform this equation, our Pythagorean theorem, into our first equation. into our first Pythagorean identity.
R is
Why
one.
that one?
Why that one? Well, just because that's where this comes from. This specific equation comes from doing the Pythagorean theorem and using the unit circle.
Okay.
So we have to use the information that we know about the unit circle, the information that we know about the trig functions using the unit circle,
Okay.
and that should get us to here.
Alright.
So what do we know about the unit circle that pertains to our Pythagorean theorem that we came up with?
Your radius is 1, and that's why it's 1 over there.
So our R value,
Oh, you did section that.
You're right.
our R value is 1, right? With the unit circle, you always have a radius of 1. So that means that our R squared value here equals 1, because 1 squared is 1.
Sure.
So now we want to transform this into this. So we need to get cosine squared and sine squared. So thinking about the unit circle again and what we know about cosine and sine. What do we know about cosine and sine pertaining to the unit circle?
They both have a
They
half.
involve the radius.
They both involve the radius.
They're both over 1.
Y over
So they're both over 1. So we know that cosine and sine are something over 1, because that's our R value.
Y and X.
So which is which?
Cosine is x over r,
Yeah.
and then sine is y over r.
So cosine is x over our R, which in this case is 1.
Okay.
And sine is our Y value over our R, which is 1. So we know that then cosine is just equal to x, because anything divided by 1 is itself. And the same thing for sine. So given that information, what can we do with this equation?
Plug it in.
So we can plug it in.
Let's look at it.
So we know that cosine is our x, so this becomes cosine. We keep the squared. So by knowing this information about the unit circle, we can transform our regular Pythagorean theorem into our first Pythagorean identity.
What purpose did that serve for me? That sounds really stupid. That's a genuine question. Like, what is this accomplishing?
So what we're doing here is we're showing where this comes from, so that you know where it came from. Like, essentially, we're almost doing a small proof here.
Okay.
Like, we're proving that this is actually what it says it is. Does that answer your question? So we're just kind of proving that this actually does work. That this is an actual equation that you can use. And you're going to use it later when you're proving other identities. So now
Thanks, Regine.
So now we're going to look at the second one. So that's this 1 plus tangent squared equals secant squared
Yes,
x.
it is.
And those second and third equations both come from this first equation that we just created, or that we just showed was a good equation. So we want to get this 1 plus tangent squared x equals secant squared x. We want to create it from our first equation that we just solved.
Sorry,
So we want to get 1 plus tangent squared x equals secant squared x. We want to get this from this first one.
Okay.
Wait, so now we're getting this.
So now we're developing the second equation from the first one.
Wait, did we ever solve the first one?
Yeah, we proved that it was cosine. We were just showing how you got the cosine squared x.
So all we were doing was like the
transitive
Pythagorean theorem and all that stuff, and that solves that one?
Staying
Well, I guess.
So transitively is the very first equation that we use to get the cosine squared x plus sine squared x equal to 1, the same as the 1 plus tan squared x to secant squared x.
So wait, so, okay, so,
You took the first equation to make the cosine one, and then
Yeah.
you're taking the cosine one to make the tan one. So transitively, does that make the first equation? Does that mean you can take the first equation and get it to 1 plus tan squared x?
so, okay, so essentially what we're doing is we're transforming this first equation into the second equation.
Yeah, he's saying,
Is that what you were saying?
no, he's saying it's the first.
The very, very first one that we
Yeah.
got to get the cosine squared x.
Yeah.
Right. So if we can get it to that, transitive, and we're getting the cosine to the 1 plus tan squared x,
Uh-huh.
does that mean transitively, the first equation you can just take directly to the 1 plus tan squared x equals secant squared x?
Saying, can't we just use the first equation and solve for the second, for this one?
Yes, they're substitutes.
Yeah,
Yeah.
Okay.
yes, sorry, I was like lost for a second, but yes.
He's using big words.
He is.
I use that for proofs. Transitive properties like for all proofs I use.
Okay,
Nick, no
So-
one has time for your vocabulary, honey.
so if we wanna go from this first equation to our second equation,
It's all-
we're going to have to do something to our first equation. We're gonna have to perform some sort of operation.
Which try 50
And it's going to be, we're only going to do one thing. We only have to do one thing to get from this equation to this equation.
Inverse?
What about the cosine, Sam? What about it? I am interested.
Say what you said.
Well.
I
But
gotta.
yeah, she came with that.
Yeah, but
cosine, you know.
cosine with the inverse
Opposite
of
of
secant.
Yeah,
Okay, so,
And then-
okay,
and then
okay, wait,
turns
wait,
off
so,
by
Hold
itself.
on,
And
hold on.
then you have like the sine, which is the sine and cosine. Yeah.
so what are you doing then?
Divide by cosine.
So we're dividing by cosine. So we're gonna take cosine squared x plus the sine squared x equals 1. And we're gonna divide everything by cosine squared x. Kinda hurts a little bit. Are we thinking?
Too much.
Adding
Were you thinking with
letters.
the nose?
Okay,
See, letters are meant to be added. You're right about that.
so when we divide cosine squared by cosine squared,
One.
it gives us our 1. What's sine squared x over cosine
I
squared
guess
x?
it's tangent.
Well, if we take away the squares, what's sine over cosine?
Opposite.
And then adjacent over. So that cancels out the hypotenuse and becomes opposite over adjacent, which is tangent.
Okay, wait.
It's over A because.
It makes
So you guys are going back to your definitions.
Yeah.
It makes
We gotta cancel out the
sense.
hypotenuse within this, yeah.
I mean, it makes sense.
But
to
what
me,
did we
because
say?
don't-
But what did you guys know what sine over cosine is?
Yeah.
Do I?
I made it make sense. I made it make sense to me. So
Well,
can we not just explain it? Can we not explain it any other
Cosine
way?
is like x over 1, so wouldn't they equal x and then
You
x
just-
over y and then isn't that tangent?
Sine over cosine.
So it's tangent. Sine over cosine is tangent. You guys said that it was tangent.
Why over?
Yeah.
Why did you change your answer?
I didn't say yes or no. We did it.
I don't.
Which equals tangent.
Why?
So why is sine over cosine
Yes.
tangent?
Yes.
Okay.
Is it that? Yeah.
So if we look at sine
That's what we said.
Good job.
over cosine, how do we define sine?
Opposite over
Yeah.
hypotenuse, and then are you just multiplying that by hypotenuse over adjacent?
And then what's
canceling out
cosine?
Adjacent over hypotenuse, and then you just like flip them, and then your x or your h's cancel. Is that how you're getting the?
So you flip and multiply like we did.
Yeah, that's what it just kidding.
I thought I was going off on a. I thought I was going off on a tangent, and
See, that's what I did to make it make sense to me. I didn't want to.
So is this what you guys were explaining?
Yes.
Okay, so what's opposite over adjacent then?
Tangent.
We got it.
Is our tangent.
We got it.
Okay,
I love it when stuff makes
as long
sense.
as we're
I
good.
put my head down for a second. Look on.
More than good.
He looks up at the system.
Alright, and then what's our 1 over cosine squared x?
Secant
Secant.
squared x, because 1 over cosine is.
gives us our secant
Yes.
squared x.
It's a bit chilly.
Because this is,
I love
the
it when
reciprocal.
stuff makes sense.
Like right here. It's cold.
Maybe it's all that.
so
hot
that's how we
air
develop that
going on.
second equation.
I said it's cold.
Sam and Robert, put your phones away, please.
Cold. Oh. Bang bang. Shots
So, alright, so that's how we get our second equation. Again, these are identities that we're gonna wanna know for later on. We just wanna make sure we know where they come from. Alright, so now our third one.
Yeah, it's cotangent squared x plus 1 equals cosecant squared.
Okay, so now this time we
Jasmine's
have,
doing like cross hatching on like her shading. She's like shading a triangle.
You see hearts on her paper.
They're like graphically, comically correct. She's like pebbling.
So we're taking the cosine squared x. We're taking that first function. Is that that?
alright, is everybody paying attention?
Yes.
Alright, go ahead, Brett.
So we're taking the cosine. We're taking the first equation and basically every other equation we're just transforming it into that.
For these two, yes, or for
For these
these three.
for these
That's how we're
three?
developing these, yes.
Okay.
So now this time, we want to take our first equation and we want to transform it into this equation.
Okay.
Got it. Okay.
So again, this time, we're only performing one operation. So what are we doing?
Divide it all by sine.
We're dividing by
I was
sine.
looking at the other one.
This time.
I was
Oh.
going
That's
backwards.
what Jasmine.
Let's do it backwards.
Yes.
Mhm.
Yes.
Yeah, sign.
Okay.
Alright, so you guys want to divide by sine. So we have cosine squared x equals sine squared x, or equals 1. And you want to divide by sine squared x this time?
Yeah.
Yes, honey. Yeah.
Okay? So, this time we have cosine squared x over sine squared x. What does that become?
Do you want us to actually write down
Cotangent.
what it looks like, or are you just gonna say cotangent? Call it a day?
Do you want me to write it out?
Yeah.
Yes. Well, we all know it's right there.
If you know that it's
We know.
cotangent.
Well, I know it's cotangent because we're writing
Cotangent
to
squared x
cotangent.
plus 1 equals cosecant squared x. Good enough.
There's just a lot of words.
Could you go back to like
It's too early for
double
this.
math, like
Give me like a
7.
give me like a 1-minute multiplication test, like
I should
1
still
through
be
10.
asleep.
Oh my god.
I don't wait
Alright.
until 1.
I'd pay for that.
Okay, so for our third one, we divided by sine squared x and we get that third equation.
Same.
We're not gonna use this.
Okay. I can do this.
In your sleep.
So, these are the three equations that our three main equations that you're going to want to know because they are going to be very important in proving other identities.
Well, we have
You're
to
going to
memorize
need them. What?
We've got to memorize them.
For the time being, yes.
What about identifying myself? They took identity out of our curriculum, and I wanted to take that this year.
Me
Took it
too.
out.
Okay.
I need to find God.
Alright.
Lord, take.
So now,
I'll get you Bible, it's all good.
Okay.
I need everybody back up here.
We're good.
Back.
Alright. So for these three identities, we might want to look at different ways of writing these three identities that might also be helpful when we're solving other identities, when we're solving other problems using these.
Yeah.
There may be other arrangements that might be helpful to know. So in this case, so for our first one, we have that we've solved cosine squared x plus sine squared x equals 1. Well, what if in my proof, I need to know what cosine squared x equals?
So, one more time.
I'm sorry.
Okay,
One more time.
when in my proof,
Your proof.
that I happen to be doing.
Okay.
What if I need to know what cosine squared x equals?
1 minus
One minus
sine the square root of
sine.
x. Yes.
So we could just rearrange it that we would have cosine squared x equals 1 minus sine squared x.
So 1 sine of x squared
Wait.
equals
So,
Yeah.
1 minus cosine squared x.
so if I was looking for a cosine squared x, and I had this in my proof, I had the 1 minus sine squared x, I would know that that equals cosine squared x. So I could do a substitution that way.
Yes.
Yeah.
We'll see that in actual examples. It's kind of hard to abstract it right now, but
So,
yes, Shimon.
My fluid
Never mind.
intelligence is
Never mind.
for
I'm
this
ahead.
abstract reason.
You're ahead.
yeah, let's
Stop.
ask you something about this. But
Okay. So is there anything else that might be useful out of this first equation?
Sine of
what side
squared x equals 1 minus cosine.
So I could solve for sine squared x.
Yeah. That equal 1 minus.
I don't really think there's a
Wait,
area.
we turned the page?
I know. I just-
Okay.
She's talking to herself.
She's in middle.
Please.
That's all.
Shade.
That's all.
So yeah, so those are the only like really useful ones that we can use for that.
Yeah, I can see that.
Yeah, and then the second one you can do.
So then what do you want to do for the second one, Shemaya?
You can see what one is.
So we could set it equal to 1. Okay, so if we want it to equal 1, what do we have to do?
1 is universally
You
recognized
can
as.
do secant squared x minus tangent squared x.
What's 2 minus 1? Secant squared x minus tangent squared x. Kindergarten just got a lot harder. Kindergarten
Ladies
just got
in
a
the
lot
back.
harder.
What are you looking for? Where are you looking?
Where in the package? She just doesn't understand.
So I would write, okay, so these rearrangements I would write near where we proved how we found each of these. So I would write these
First page.
by problem 1. I would write this one by problem 2. Does that help?
I see what you're getting at.
I mean, you could write them on the 3rd page too. It's up to you. I didn't specifically give you a spot to write them. Alright, so what else can we do for our second equation? What else can we solve
You
for?
can find that secant. You already have that secant squared x does equal to 1 plus tangent.
Okay?
And then you can solve for tangent.
So we can
squared
solve for
x,
tangent.
Which is just secant squared x minus 1. It's just a mouthful. That's really all it is. It's just a lot to.
Yeah.
I have a camera in my face.
Alright, and then our last one.
Now I just what your future career is. As an actress.
Before the seniors go, can we sing
Yeah.
karaoke in this class?
Off topic, Regina.
No, we have the best karaoke system ever.
Alright, so what else can we solve for in our 3rd equation? We've already solved for
I
cosecant.
got something.
What do you got, Nick?
Okay, so you can also solve for 1 in this one.
Okay,
So, so you have that, hold on. Okay, so you have negative cotangent x squared, or whatever, or cosecant x squared x minus cotangent squared x. But if that also equals 1, then wouldn't that make that equal to secant squared x minus tangent squared x?
Stop. Stop.
I mean, he kind of makes sense.
No, it
Yeah.
doesn't.
Okay, hang on.
It transitively makes sense.
If we're using the transitive
The
property,
transitive property
what he is
makes sense
saying
here.
does make sense.
He's just getting ahead of himself. He's adding
But it's not
stuff to my
necessary
brain.
right here.
okay. So hang on, let me get that wrote down first.
Time to take a nap.
Nick, what do you do?
I had to throw a paper towel away, pardon. My lip was bleeding, God.
Okay. So Nick, so you're saying if we know that 1 equals
That,
That
and
and
must
that-
be equal to that.
that those two are equal?
Yes.
Yeah.
Yeah.
It's
Why
true.
Is that true?
Yeah. It is
It's a legitimate.
Do you want proof? I'll write it out for you.
I don't know if that would necessarily be useful. Well, it depends what you're solving
First
for.
time admitted, math is not useful.
No, I just don't know how useful it would be in the proof. I mean, if you're given that secant squared minus tangent squared x, and you know that that equals 1, and you're trying to get to this, well then you could do the substitution because you know that they're both equal to 1. But how often you're going to do that, I don't necessarily know, but that's a good connection.
Well, how often am I really going to do any of this?
And you know, addition, subtraction, division, multiplication, I'm good.
Good on fractions.
Alright, so then our last,
Grade.
what's our last kind of rearrangement that we can do?
Solve for cotangent.
Solve for cotangent.
Yeah. Squared x.
You know what?
But no, that's a good connection, Nick. Like, I didn't even think of that. That's,
It makes
Good
sense.
for you, Dad.
The more you know.
I mean, it makes sense.
it does.
Oh.
Okay, so those are our 3 Pythagorean identities, and then our kind of rearrangements of each.
Yay.
So now we want to look at the other useful identities that we might need when solving these kinds of problems. So now we're at the quotient identities.
There's more.
So if we're looking at the quotient identities,
You got tan x.
what is a quotient?
Division.
So it's a division or a fraction or a ratio or something like that, yes.
Of the sort. Correct.
So if we are looking at tan x, and we want tangent of x's quotient identity,
Yep.
what would tangent of x's quotient identity be?
Opposite.
Oh, we literally just did that, so it's.
We did.
I literally
Y
just
over
did
X.
that.
Sine.
X over Y.
Tan x.
Sine x over
Y
cosine
Sine
x?
x.
Yeah.
No, wait.
Sine
over cosine?
squared x over cosine.
So we're just looking for tangent of x this time, so it's just sine x
Oh yeah, that's right.
over cosine x.
Why is she sinning?
And we actually did prove that one that we did through the opposite over adjacent and all that.
So wait, okay.
Oh my god, I remember walking into pre-calc class last year, seeing them do this, and now it's like hitting me.
So that's our tangent x. And then we also have
Carrie's not go.
cotangent of x.
So cosine over sine.
X.
So cosine over sine.
Yeah.
Don't forget the X's.
Okay. So those are our quotient identities.
Don't say that.
Virginia.
I'm sorry.
Alright, so then the last identities that we want to look at before we actually start solving some of these is we're going to look at the negative angle identities. And before we define those, I have 6 examples that I want you guys to look at. With each of those examples, I want you to tell me which ones are true and which ones are not true.
Okay. I got this. No, I don't.
So for the first one, you're looking at sine of a negative pi over 4 angle, so you need to find what the sine of a negative pi over 4 angle is. And then you need to tell me whether that's equal to negative sine of a positive pi over 4 angle. Are we confused?
No.
Not really.
Okay.
What do you hear that?
Alright, so,
Numbers now?
okay,
Are we using the triangles?
yes.
Oh.
This is going to go back to using the triangles.
Okay.
So this goes back to your opposite over hypotenuse
Yeah.
and your 45, 45, 98 triangle, your
My
36,
brain's shutting
90.
down. I'm sorry.
Got it.
So I want you guys to work on these 6 examples. Tell me which ones are true and which ones aren't true. And then we're going to go over why they are and why they aren't.
Okay.
False. False.
May I use it?
Yes, you may.
So Charlie, stop
Process is
recording.
9 days off.
Just like,
Yeah.
Charlie, stop recording then, or should we just like let it pause?
No, just let it go.
Just let it go?
Yeah.
Can I use a calculator? Or is that cheating?
Do you need a calculator?
It is. We're currently on camera.
That actually takes like
I mean, can I use one of the cosine sheets?
Why do you need to cheat?
Because I just feel like it's a lot of brain power involved, just a lot of drawing. And
Alright, working on the examples. This is not free time. We're working on these examples.
So can I use like to kind of stuff
Oh, yeah. This is not working. Very much not working.
You're right, the only number that we've actually talked about so far
what
is
does
one.
negative mean?
It's a good number.
Many things equal one somehow.
One is a very good number. 5 minus 4.
I don't think one.
Cosine squared.
I don't know what I'm doing.
Where?
Yo, necesito helpo.
Where you been?
Helpo.
Oh, how you gonna do?
28 this month.
Me too, it's okay. What now?
What you got? Composite.
Down. Does it go down?
Yeah,
It's
so
like,
you're on out.
where am I drawing?
Not that much.
No, I hate this.
Oh.
Wait, Denver, what was your
Okay, so where is it?
It's not like right here.
No, I said.
Oh, okay, he just asked me that, and I thought it was you, and I was like,
I'm so jealous. Maybe that my school would have accepted me.
Okay.
yeah,
So
that's
then you try and find the sign.
So it's 1 and 1.
It was living.
Wait, I don't know. It's between in the end though.
I give 2 to you.
I got to go meet Mary.
Negative sign is all students take calculus.
Okay.
So that'd be the down.
Alright, so you need to find the sign of a negative pi over 4.
HIPAA.
So where's the negative pi over 4?
Wait,
What?
what?
I
Alright,
don't
what
know
is,
the end.
what's pi over 4? So pi over 4.
What is the end
I'm trying to
goal?
figure out if
Because
it's
like, I was
true
really
or not.
conscious, like, that's why you
So,
So where's the
so
negative?
that
Yes, it is.
sign negative times
So you're going to negative 45, right? So find the sign of a negative 45 degree angle.
No, but me and my dad did that
If you have to.
No, we tried to look for the channel.
Okay. So
Okay, what'd you ask, Jeff?
what are we trying to find if it's like true or not? So like
So you need to tell me if the sign,
can I just tell them right? Is that true?
I attended the
Because
lecture.
it can be down here because sign's negative and sign's down to negative.
so you have to tell me what the sign of this negative pi over 4 angle is. Is that equal to negative sign of positive pi over 4 angle?
So can I just write true?
You have to be able to explain it though.
Do I have to explain it right because I'm not a writer.
Are you gonna remember why it's true?
Yes, because I have this.
There's so much
If you know what you're writing down.
This way?
Yes.
No. The big question is,
that you did something wrong.
the smartest thing about guesses, like this is what I believe, because these are obviously not true.
Negative
But
half
when you consider that a negative right from that sign, is that just basically taking that angle, like making it negative?
So, okay, so here, when you have the negative out front, what you're doing is you're gonna find sign of the pi over 4 angle.
That overlaps.
And you take your first, and then you're taking the negative, whatever you find.
Well, essentially, it's the same thing as that.
Well, what's the sign of pi over 4?
Sign of pi over 4 would be, let's go. So it's 1 over pi over 2. Pi, yeah. Pi, square root of 2 over 2.
Yeah. So then you're taking the negative of that.
Yeah, that's messed up.
So you get negative root 2 over 2.
Negative root 2 over 2.
Does that equal the sign of this negative one? Taking it in the negative sign.
Yes, because you're still getting negative.
Yeah, no,
If
but
you do it down here, you go for negative. The opposite is you
That's
have
better
one
off.
over that, distribute that across, and you got still come up with that negative.
Yeah. So that's how you show that that's true.
It makes sense now.
And you're doing that for each one.
I didn't mean to.
Do you have a question?
Yes.
Okay.
You don't do that.
This is probably.
Now your name is Jasmine.
So where is negative? Where's negative pi?
That's her name.
That's slang for something in Spanish. Hold on.
Not thinking about cosine.
Probably
Thinking
just
about
like
the energy
one,
itself.
just like proof and like trials and
Just one over
everything,
one.
you flash check it, and then prove
Do you know
whatever.
what's going on? Look at what I did to my paper. Like, I
And
can't
then
hit
you get to see what which one it is, and they just didn't know what it was.
Oh my god.
I don't know, this people on Facebook.
Wait.
It was like,
What's that?
what?
If you guys are having an issue with this, think about drawing
Is
it.
it just one over square root?
So, okay, so you get
Like,
one.
can you imagine?
Root two.
You just give a drug.
But you're in the fourth quadrant.
So it's negative.
Making enough money at that
Right?
point.
Are you just
People are just
getting?
so greedy. It's just
No, because you said I had
Medical
to make
careers
negative.
or medical profession's really flawed. It really is because it's very money driven. And it's kind of a shame.
It's a shame. It is a shame. Bad ridiculous.
Here you have to find the
But
sign.
until then, you know, like I went to state for the week.
So you have
That's
to
how my
actually
door
use
is.
that.
My roommate,
Find that sign.
all that good stuff. So.
You all like just don't want to
If I'm
draw it
going to
out.
big state,
Draw it.
you know, I could go there.
It's art class.
Eric?
It's not a bad school. It's not a bad school at all. And it kind of like lessens the blow.
That's my dream marriage. That's my dream marriage.
You should tell me
They're organizing
language.
My sister was.
It's honors for
This
my
is a
family.
language.
And then I
Yeah,
just
those are
start to
letters.
So find each of those.
I don't know
And
what
if
the
equal,
word
then it's
is.
true. If they're not equal, then it's false.
I mean, case is no much better. Case is not much better, but closer to Central Campus, and it's by the president.
Nino do.
I'm coming, Sean.
My sister was.
I'm trying to pack my things out and call it a day.
Is that you or her?
It was me.
Where is negative?
Occasionally it's me.
Occasionally.
Right. Not accepted.
Oh, yeah.
I just figured it out.
I don't.
You don't understand the thing?
I do and I don't at the same time. Like the thing that she just asks you, I don't know.
You said what?
This?
She-
This is nothing.
When I did school, we
Have you been to Toronto?
You're looking at
And
negative.
money's due today.
Friday.
Jazz over that would be
Money's due tomorrow.
Oh my god. Pay schools. I wasn't thinking about it. Pay schools.
The process was way
That's what I did.
A
Oh, I don't draw.
When's the grid?
So I was right first.
I
I
already signed this, but I don't know what's
Sorry, you're too late.
Right, no, Tuesday, Wednesday, Thursday.
down Thursday.
I think I'm on Wednesday. You can check in Merkel's office, she's got those
I'm
scheduled.
definitely on Thursday, I just didn't know what's up.
I gotta go talk to her actually, I forgot what it
Really?
I already have my life picked out with Michigan State, so if Michigan accepts me, I don't know how quick I'll make a response, it might take some time. I might actually think about it, which is weird, because I wasn't.
Well, if you get best of five,
The only way, like,
Definitely have
you really
best of
would
five.
get in is
Yeah, you're
if
finding the
somebody
sign.
was
hot air balloon.
maybe like high grade, honestly, way this.
No, a lot of kids, I mean, yes, financial aid, but some people apply to schools knowing you're not gonna go there. I applied to UD, knowing I wasn't gonna go there. But like, that's a frequent thing, even for university admissions, people apply to do it.
Yeah.
Are you?
Oh, whatever.
What?
Just, I mean, you know that
All right,
Maria Didio.
we're running out of time. So we will finish the negative angle identities tomorrow. I want you guys to have these pretty much figured out by tomorrow though, and we will go over them and we'll explain them.
Protein bars.